Okay, the first step in setting up a total station is setting up over a point. The steps to setting up over the point are when you get out of the vehicle, you set the tripod up with the legs closed to about chin level. Then you get over to the point, you set one of the legs up about 2 feet away from the point, put the instrument on top. There's a device called an optical plummet. You look through it, focus it to your eye, and then while you're looking at the point or somewhere near the point, you pick up 2 of the legs and manipulate the optical plummet so it's targeted directly over the point. You then have the instrument on the point but not level. To level the instrument, you manipulate the slides of the legs. You don't actually move the legs, you just slide the members up and around. When you got the circular bubble in the level, then you can go to the next bubble, which is the plate level. That's the one that's a little bit higher, closer to telescope. You have to think about the instrument as having 4 leveling screws instead of 3 because you level in 90 degrees. So you set the plate level up so that it's parallel to 2 of the leveling screws, level it, turn it 90 degrees. Now it should be over one of the other leveling screws that weren't in your area. Level that one. Then you go back to where you started and you keep this procedure up until you don't have to touch it. Now you look through the optical plummet, see where you're at on the point. If you have to move it, you loosen the fastening assembly underneath the instrument slightly, slide the instrument so it's over the point, tighten it back up, and then level it slightly. Usually you don't have to level it very much. Now you're over the point and level, and you're ready to start with the next step. The easiest way to sight the total station is to use the peep sights, which are above the telescope or below the telescope. You have 2 locks, one that works the telescope and one that works the rotation of the instrument. You release both locks, you use the peep sight on top and set it just above the target you're sighting. You lock both the lower and the upper motions. You focus it to your eye, and then you slow motion the tangent left or right or up or down to get it right on the point. If you use that procedure for sighting, it goes much quicker. When you turn the instrument on, it's the orange button. The first thing you'll see are 2 zeros pop up on the screen. It says 0 set and 0 set. With this particular instrument, you need to tilt the telescope slightly and rotate it 360 degrees in a clockwise direction. That gets the menu screens up. There are 2 basic menus we're looking for. The first one, to create a file, you hit escape until you see the main screen pops up that has the serial number and the version and the file name. And if you look, the function keys correspond to a word just above them. And I believe as F3 says mem or memory. If you select that, it'll give you some options. And the option we're looking for is job. It looks like Joe, but it's actually job. So you pick job, then you pick job selection, and then you pick any one of those jobs that you want to use that has no data in it. Pick edit, type in the file name you want to use, hit enter, and when you hit enter again, now it's selected. I usually will escape out until I can see the main screen again with the serial number and just make sure that that job is a job I'm working at. So that's how we create a job. Okay, for mapping purposes, I always work in coordinates. And the reason is coordinates are very easy to calculate and very easy to understand. Once you've created the file, if you hit escape, you should see under the functions one of the selections, which is coord, C-O-O-R-D. If you don't, hit the function button until you do see it. When you find it under the functions, select it, and you'll have 3 options. You have observation, station data, and setting the horizontal angle. In coordinates, we need to have 2 things fulfilled. We need to know where the total station is and what direction it's pointing. So you pick option number 2, which is station data. You enter the coordinates, and I like to enter 0, 0, 0. So you have 0 for the northing, 0 for the easting, and 0 for the elevation. Instrument height means the height of the instrument off the ground. The easiest way to measure that is with the prism on top of the prism pole. Put it at the same height as the little mark on the side of the instrument, and then read the height of the instrument off the pole. That is the most accurate way because it eliminates any error there might be in the pole. So we type in the instrument height, which is 5'1" or 5'2", whatever it happens to be. Then the next thing you have to enter is the rod height or the target height. and that's whatever you set your pole for. I like to set my pole at 6 feet and then enter that. You'll see a button that corresponds to a function key that says OK. Once you've hit OK, that's selected and you're ready for your next step. Your next step is to set the direction or set H angle. Select option number 3, which is set H angle. You take your telescope, your instrument, you sight on a permanent target or a permanent mark, something that's going to be there for the duration of your measurement time. Sight on it, and the angle I like to use in training is 0 degrees. What that corresponds to is a top left-hand corner of your page, or a north azimuth. I don't like to get hung up on the compass directions. It's more just to get the map into the computer. You can rotate it any way you want later. Just set 0 degrees as your angle, and now you're ready for observation. Observation is the actual mapping. Okay, now that we've gone through the general setup procedures, we're ready to start mapping. From the same coordinate menu, your first selection is observation. Observation means take a shot. So we'll take an observation, and then if you look at the function keys, one of them says REC for record. In other words, record the data that was just shot. So we record it. It wants an item number, and it needs a code or an item description. If we're doing evidence, like in an evidence log, then logically we'd start with 1 and then sequence through, and whatever the evidence item is, that's what we type in for code. If we're mapping, like the edge of pavements or the lane lines or skids, here's where you're going to type in the descriptor for the code. The different softwares we use are Map Scenes, Map Vista, and Crime Zone. Crime Zone is the easiest because Crime Zone doesn't force you to use any descriptors or any known codes. You can use anything you want, you just have to be consistent. So if we're measuring 2 skids, all we got to do is the first shot on a skid would be skid, the next shot on the same skid would be skid, and the next shot would be skid. The skid mark next to it we give a different name as we don't want to connect the two, so that would be like skid 1. If we're shooting edge of pavements, we can call them EP, we can call them S, we can call them SW, anything you want, just as long as you're consistent. For evidence items in Crime Zone, since they can't be the same one or they'll be connected with lines, you want to number them. So if you have shell casings, there'll be shell casings 1 through 16. And then you'll have them all on the screen and they'll all have the descriptors next to them. For Map Vista and Map Scenes, we need to use the codes that are in the software. The easiest code file to use is called KISS. What that requires you to use is S for solid lines and D for dash lines. If they're evidence items, you just type whatever it is. So if you want to make a solid line, it's S. A solid line next to it would be S1 up to infinity. If you want to use colors, SB is solid blue, SR is solid red, SY is solid yellow, SG is solid green, and it goes the same for dashed. And again, you can use 1 through infinity. So you can draw any number of lines just by using the consistent codes and take it into the KISS code file in either Map Scenes or Map Vista. Besides the general line work, the students can get as detailed as they want to on the extra items such as signage, fences, there's some catch basins here. They also want to get the % grade of this road. Usually what I'll do is I'll have one file for my line work, and then I'll have a separate file for my evidence items, and that way I can have the evidence log and the evidence items match numerically. Basics of mapping are what we're using here for the crime scene. The basic things you want in your diagram is it has to be familiar. It has to look like the area we're mapping. It needs to be accurate, which means you have to be careful. And the most important point for crime scene mapping is it has to be reliable. You can never put on paper what you didn't actually see with your own eyes. The acronym is FAR, so it's got to be familiar, accurate, and reliable. The 3 basic things which we teach in mapping as far as the setup is it has to have an origin point. Generally it's 0, 0, 0. It's where the total station is set. We have to have it oriented to a direction, which is 0 degrees, which would be the top of the page or north. And it has to have reference information. In the case of this particular scene, our reference information are the edge of pavements. That way we can come back out here and recreate the scene with any 2 points previously shot. Since the total station is just a computer, we can hook it up to the other computer to download. When we're using Crime Zone, we have to have an ASCII file first, so we can either download into WCOMS or into Map Vista. And of course, Map Vista is a standalone product where we can do all the editing in there also. The only things we have to make sure of is that we're using the right COM port on the computer, the baud rate is correct, And if we're using any of the Windows type communications, we have to make sure that the COM port is free so that the total station can communicate with the computer. Okay, troubleshooting usually entails just descriptor mistakes. If a mistake is made in the field where you entered the wrong descriptor, rather than trying to correct it in the field, what I'll usually have the students do is just mark the point number and what it should have been on a piece of paper. Then when they come in and download it, they can fix it there. A common mistake I see with beginning students is they'll do all of their field work, come in, download, and go to map, and they have no lines or lines that go everywhere. And that's almost always going to be a descriptor mistake. So that's the most common troubleshooting error I see. Okay, the differences between the two total station types, the 110 and 120 series, and this instrument, which is the 30R series, is in the keyboard. You have less keys to select from, so you have to pay more attention to the menus. To set up a job, you have the same prompts, just in a different order. You have station orientation. This is where you enter your station coordinates and set your H angle, just like we do in the 110 and 120 series. And then we have the observation, where we're going to take our shots and enter the descriptors. When we take our measurements with this instrument, it doesn't have a big enough screen to display the descriptor. So when we're in that field, we need to arrow down until we can see the descriptor to enter it. Okay, so we set it up in the doorway over the point. We zero set it to this door jamb. And we turn it and measure the walls. The last point for mapping is that the likelihood of you testifying and supporting your map is very strong. From the FBI point of view in the class that is taught called Post-Blast Investigation, Large Vehicle Bombs, we always like to have the north arrow pointing up. We like to have somewhere on the diagram for reference only or not to scale. And also, if you take digital images of important items which don't seem to fit the map, in the case of where we're at here, sometimes the edge of pavements don't go in a straight line. You'll have a radical jog or you'll have a big hole in it. Sometimes, if you map it that way, you need to take a digital image just to support it later because you may forget. And the most important point as far as the FBI is in details. You don't want it to be so detailed that a defense attorney can then pick on the details and ignore the evidence. Okay, this has been a very brief outline of how to set up and operate a total station for mapping and diagramming. If you want to know all the functions of the total station, you need to refer to the manual. Also, there's several other courses that are offered by different federal and state agencies on how to do accident reconstruction or crime scene mapping.